in this video, I will explain the solution of partial differential equations using the method of separation of variables. Consider, for example, this differential equation, this partial differential equation in cylindrical coordinates. Rho, phi, and z are cylindrical coordinates. So the equation or the problem depends here on two variables only, namely rho and phi. Rho squared, the second partial derivative of u with respect to rho as function of rho and phi, plus rho times the first derivative with respect to rho as function of rho and phi, of course, plus the second derivative of u with respect to phi as function of rho and phi is equal to 0. And we have certain boundary conditions here given to complete the solution of the problem. The first step always in the method of separation of variables is to assume that the total function, the unknown solution u, is a multiplication of functions each of the one of the independent variables. So capital R is a function of only rho, and capital phi is a function of only phi. Okay. Now the second step is to substitute this assumption or this solution in the partial differential equation. So rho squared, we derive this u here twice with respect to rho plus rho, and we derive this u once with respect to rho, plus we derive this equation twice with respect to phi. The result is this: rho squared r double dash phi plus rho r dash phi plus r phi double dash. Now the third step is to divide the whole equation by u. U is equal r times phi, as you can see here. So if you divide this by r and phi, r times phi, okay, capital phi, and also you divide this by r times capital phi, which is u, okay, and also you divide this by r capital phi, and 0 by r capital phi is 0. Okay. Now here in the first term, phi will cancel with phi, and we will end up with rho squared times r double dash over r here. The second term also phi will cancel with phi. Capital phi is the function. Small phi is the independent variable, the angle, while capital phi is the function. The result is rho r prime over r here. And the last term, r will cancel with r, and we will end up with phi double dash over phi equal to 0. The next step is to separate the functions. We want one term in terms of rho only, which depends on rho only, and we want another term which depends on phi only. Phi is small phi, which is the angle. So note that this term depends only or is a function of rho only, and this term depends only on small phi, which is the angle. So each term should be constant because their addition is 0. Even if you change, if you vary rho, or if you put different phi, you will obtain 0. This means that each term should equal to a constant. Otherwise, if they are variable, not constant, they will not add to 0. So this term, rho squared r double dash over r plus rho r dash over r, we assume that it is equal to this parameter, lambda. So the second term, phi double dash over phi, should equal minus lambda because their addition is equal to 0. Lambda minus lambda is equal to 0. Now, this is an ordinary differential equation of second order with variable coefficients. And this is an ordinary, not partial, differential equation of second order with constant coefficients. Now, if you multiply the first equation, this by capital R, because we want to eliminate R in the denominator. So R rho squared, R will cancel, R will cancel here, and here we'll have capital R. Okay. So it will be rho squared R double dash, rho R dash, minus lambda. You take this to the left side, it will be minus lambda times R equals 0. The second equation will be phi double dash plus lambda phi equal to 0. Now we solve each equation separately, okay, and we apply the boundary conditions to obtain the unknown coefficient. This is all about the solution of partial differential equations using the method of separation of variables. I hope that this video will be good for you.